Welcome to the Explainer. Today, we're going to do something that sounds kind of crazy. We're going to take a journey through an entire year of foundational science. We're talking from the absolute tiniest building blocks of life all the way up to the grand scale of our planet. And we're going to do it all in just about 5 minutes.
Sound impossible? Well, you might want to buckle up. We are going to connect the dots between biology, physics, and geology at lightning speed. And we're going to focus on the core ideas, the ones that make everything just click. You ready? Let's do this.
All right, so our journey has to begin at the smallest possible scale, right? We're diving deep into the world of the cell. This is the starting point for absolutely everything, from a single little bacterium to the trillions of cells that make you, well, you. These microscopic units are the foundation of it all.
And you know, what's so cool about the cell is that it has this dual role. It's both the structural and the functional unit of life. Think about that for a second. It's not just the bricks that build a house. It's also like a tiny engine inside every single brick that's powering the whole operation.
And this is where it gets really interesting. That basic cell model, it has all these amazing variations. For example, a plant cell has a rigid wall that gives it structure, which is exactly why a tree can stand so tall. But an animal cell, it has a flexible membrane that allows for movement, for complex shapes. This one tiny difference is the starting point for all the crazy diversity of life we see. And that variety exists even within the same kingdom.
And this is a perfect example of that. It shows how a tiny difference inside a seed, literally whether it has one seed lobe or two, scales up to define the entire plant. You've got monocots with leaves that have parallel veins and these fibrous roots, kind of like grass. Then you've got dicots with branched veins and a big main taproot, like you'd find on a mango tree. And it all starts with that one tiny detail in the seed. It's incredible.
Okay, so we've got these incredible, intricate biological structures. But, a structure by itself is just a blueprint. What actually makes it all work? Well, the answer is energy. It's this invisible current that animates everything from a single cell to a giant star.
So, the first thing to get your head around with energy is that it's not just one thing. It's more like a whole family of forces. You've got kinetic energy, which is the energy of motion, and potential energy, which is stored up. But it's also in light, in heat, and even in the chemical bonds of the food we eat. The real magic, though, is that they're all interchangeable. They're constantly converting from one form to another. So let's look at an example you probably know well.
Static electricity. Come on, we've all felt it, right? That little zap when you touch a doorknob, or when you rub a balloon on your hair and it sticks to the wall. It is a perfect example of this invisible energy that we can actually generate ourselves, just by rubbing two things together. So what's really going on here? Well, down at the atomic level, that simple act of rubbing is actually a pretty dramatic event. You are literally scraping negatively charged electrons off of one surface and piling them onto another. And that imbalance, way too many electrons over here and not enough over there, that's the source of the charge. That's the spark. That's the magic.
Okay, so that electrical charge is an invisible force. But what happens when these forces scale way up? Well, that's when we enter the world of physics, the tangible, everyday rules that govern how things move, how they stop, and how they interact with each other.
And this is just a brilliant way to explain a kind of tricky physics concept. So, imagine you're running a 400-meter race on a track. The distance you've covered is obviously 400 meters. But your displacement, which is the straight line measure from where you started to where you finished, is 0, because you're right back where you began. It's a fantastic reminder that in physics, the path you take is just as important as where you end up.
And the engine behind all this motion is, of course, force. But force isn't just a simple push or a pull. No, it's way more than that. Think about kicking a soccer ball. In that one single instant, your force takes an object that was at rest and moves it, it changes its direction, and it can even change its shape just a little bit on impact. Force is basically the fundamental agent of all change in the physical world.
And now for our final and most dramatic zoom out. We've gone from the cell to the atom's charge to the forces that push and pull around us. So let's apply all that thinking to the biggest object we all know and love, our own planet Earth. Just look at this. Get some perspective here. We live our entire lives on the Earth's crust, but it's like a paper-thin shell, less than 1% of the planet's total volume. Almost everything, the massive mantle, the incredibly dense core, is happening right underneath our feet. It really puts our little world into perspective, doesn't it?
So how can we even begin to visualize these immense layers? Well, there's a surprisingly perfect and totally memorable analogy for it. A hard-boiled egg. Seriously. The fragile shell is our crust, the thick egg white is the mantle, and that dense yolk in the middle, that's the core. It's such a simple, brilliant way to basically hold the entire world right there in your hand.
And that thin little crust we live on, it's not static at all. Not even close. It is in a constant, super slow-motion cycle of renewal. You have molten magma that cools and hardens into new rock. Then, over millions of years, that rock gets weathered down into sediment, which gets crushed by immense pressure into a new kind of rock, which can eventually get so hot that it melts back into magma to start the whole journey over again. It is the ultimate recycling program.
So, there you have it. In just a few minutes, we've blasted from a single cell to the invisible dance of electrons, to the forces that move our physical world, all the way to the immense geological cycles happening deep within the Earth. The big takeaway? The rules that govern the smallest things also shape the very largest. It's all connected.
So from a single cell all the way to the planet's core, this is the scientific foundation of our world. These are the fundamental rules. This is how things work. So the only real question left is the one for us. Now that we know the foundation, what are we going to build on top of it? Thanks for joining me on The Explainer.